Here we go. So, yesterday we were discussifying two-dimensional motion, and basically the gist of it was that you need to keep stuff separate, right? You write stuff in vectors. So, in the example we were talking about, we had this drone that was driving around in stupid miles per hour instead of meters per second. So here's our position in miles and hours, and our position in miles and hours. And so what we discovered was that if you differentiate the x position, it gives you the x velocity. And if you differentiate the y position, it gives you the y velocity. Were there questions about any of that? Everything else works exactly the same as what we've been doing. If you want to find average velocity, you got to do displacement over time. If you want to find instantaneous velocity, you take a derivative. It's all exactly the same. All right? So what we need to talk about today, then, is acceleration. Okay? So, let's do that. No, we did all that, we did all that. Here we go. So, acceleration. Again, it's exactly what you'd think it is. Acceleration is change in velocity divided by time. Okay? So, to put a fine point on it, let's go back to the drawing here for a minute. Well, here, let me do this. So one of the questions is going to ask us to find... Sorry. So one of the questions wants us to find the acceleration after 2 seconds. Okay? So, what that would represent pictorially is the following. Where is my giant map of... There it is. All right. Let's embiggen the screen. Let's clear all the ink. Okay, so we decided that the drone was right here after 2 seconds, right?
2 hours.
2 hours, thank you. It's going to happen. Stop correcting me, just be a little.
No,
all right?
I absolutely refuse.
Okay, so let's think about what the velocity was just before that instant. Just before that instant, my velocity was something like this, right? Does that make sense? Okay. And then it looks like it's speeding up, right? How can I tell by looking at this picture that it seems to be speeding up? What do you got, Peter?
Because the slope, like as you keep going, the slope gets more, like, or less and less gradual.
Okay. So you got to be careful. This is not position time or velocity time. Do you know what I mean?
Yeah.
So Jen, what do you got?
The dots get bigger.
Good. The dots are getting farther apart. Remember, each of the dots represents the location at evenly spaced time intervals, right? So if you go from here to here to here to here, the dots are getting farther apart, indicating that it's going a little bit faster, right? Okay? And it looks like that kind of continues. I don't know at what point it stops. It's tough to tell if these are farther apart or what. But I think we can all agree that, well, so I guess let me pause for a minute. What does this little red arrow that I just drew represent? Instantaneous velocity, right? Okay, literally instantaneous velocity, right? Now, how long it is sort of a gray area, right? Because we don't know exactly how fast it's going at that instant, all right? Similarly, at this instant, it's kind of going this way, right? So that's my instantaneous velocity a little bit after 2 seconds, right? So look, if I think of it as this is my VI and this is my VF, then let's think about what change in velocity is. All right, so look, change in velocity is VF minus VI, right? So we're subtracting vectors. I hate subtracting vectors. I'm going to rewrite this as addition. This becomes VF equals VI plus change in velocity, right? So,
wouldn't it be VI equals VF plus change in velocity?
You're just adding VI to both sides?
My bad.
Yeah, I flipped these guys around.
I thought that you were going to, like, I was doing more.
Okay. All right, is everybody good? All right, so let's draw this. So here's my VI, right?
every day.
It even squeaked when it hit. That was very satisfying. Okay. All right. So here's my VI plus some vector has to give me this final velocity vector. Right? So that little vector there is my VF, and there's my change in velocity. This tiny little dude, right? Okay? So my guess, without doing any calculations, and I honestly haven't done these calculations since last year because I got a little bogged down last hour, my guess is that when I calculate the acceleration here, I'm going to get a vertical acceleration of pretty close to 0 and a negative x acceleration. Right? Because look, at the instant before this point, it's moving this way horizontally, right? And shortly after, it's moving that way horizontally, right? Okay? So I think that my acceleration horizontally is going to be this way. And vertically, it looks like, from here to here, it looks to me like it's speeding up. From here to here, it looks like it's slowing down vertically, right? So I am guessing that my vertical acceleration is going to be 0 at that point, because that's the point when it stops speeding up and it starts slowing down. Make sense? All right, so let's see if we're right. Me too, you guys. Oh, too far, too far. Okay, so let's go through and calculate some stuff. So yesterday we found the velocity as a function of time. I don't remember what it is, so I'm just going to do it real quick. So it'll be just as quick to just do it. So our x velocity is going to be negative 4.5 t squared plus 12t minus 4.5. And our vertical velocity is 6t squared minus 24t plus 16, right? Everybody good with how I did that? Just a quick derivative, we did that yesterday. So how do I find my x and y accelerations? Take another derivative, right? So d dt gives my acceleration in the x direction is going to be, let's see, negative 9t plus 12. And if I take the derivative of this guy with respect to t, I find out that my y acceleration is 12t minus 24. Problems with any of that? All right, so what's the question asking us to find?
After 2 hours.
The acceleration after 2 seconds. 2 hours. I just need to go back and change everything to meters and seconds because I'm never going to get it right. Okay, so what should I do? Plug in 2 seconds, hours, whatever. So acceleration x after 2 is going to be negative 9 times 2 plus 12 gives us negative 6 miles per hour squared. Good. And my acceleration vertically after 2 hours is 12 times 2 minus 24. Oh! Why am I excited? Because it's 0!
You were right.
Cool?
Yeah.
All right, so I'll be honest, I got lucky. I wasn't sure it was going to be 0, but all right. So my overall acceleration then would be, in unit vector notation, negative 6i plus 0 miles per hour squared. Capisce? That's not a word. Even in Italian, that's not a word. All right. All right, now, average acceleration. I'm not going to do it right away. Take a second and see if you can figure out how we would find the average acceleration for the first 2 seconds. Average acceleration for the first 2 seconds. Oh, sorry. That was a lucky surprise. I thought my coffee was gone. All right. So hopefully you're thinking there's only one way to find average acceleration, right?
Right.
Unless your jerk is constant, which is a whole separate thing that we'll talk about maybe later. All right. The only way to find average acceleration is to do VF minus VI over t. Find your change in velocity and divide it by time. Okay? So what do I need to do? Find the velocity after 2 seconds. That will be my VF. What else? Find the velocity after 0 seconds. That will be my VI. Subtract, divide by time. So here we go. Man, I hate this smartboard sometimes. Okay, so. All right, so here we go. Vx after 2 seconds. What was it? We figured this out yesterday. Does anybody remember what it was?
Negative 4.5. Oh, 2. Nothing mind. Ignore me. I'm being wonderful.
It's okay. Anybody got it? 1.5. I guess I could pick up my notes that are sitting. 1.5. Oh, did we find the whole velocity? So, man, I'm being dumb. Where are my notes? No, that's a test. No, that's other stuff. One of these days I'll get my head out of my ass. Oh, here. Here we go. So this was 1.5 meters a second, and our Vy after 2 seconds was 0 miles per hour. Good? Cool? All right. Now, at 0 seconds, let's see. Vx after 0 seconds, that's easy. That's going to be negative 4.5, which is what Justin was trying to say before. Our Vy after 0 seconds is going to be, what, 16 miles per hour? Follow? Everybody good? So, let's do this. So, our velocity after 2 seconds is negative, oh no, it isn't negative, sorry. It's 1.5 I. We'll worry about units later. Our velocity after 0 seconds is negative 4.5 I plus 16 J, right? Patrick, you guys good back there? This is not yelling at you for talking. Just genuinely, are you okay?
He's concerned about Vy of 2.
Yeah, wasn't it negative? I had 2 share there.
Oh, yeah, it's 8.
Oh, this was the one that I had the mistake on it. I didn't correct my notes. Thank you. What was it supposed to be, negative 8? Yeah, holler at me, you guys, when I'm being dumb. And I know it'll be a lot of hollering, but... Thank you, guys. All right, are we good or no? Good? Sorry, everybody's happy? All right, so now that I know my instantaneous velocity after 2 seconds and my instantaneous velocity after 0 seconds, what do? Subtract, right? Because remember, you guys, acceleration is change in velocity over time. So that's Vf minus Vi over t. So for us, that's V of 2 minus V of 0 over 2 hours. Sarah, you good? Yell at me when you can't see, you guys. What's the problem, Evan? All right, so let's do this. Change in velocity. Vf minus Vi, right? So I got lucky. I wrote it in the right order. So 1.5 minus negative 4.5 is going to give me 6I. Right?
Yes.
Negative 8 minus 16 is going to give me negative 24J. And that's all miles per hour, right? Everybody good? Questions?
So
v of 2 minus v of 0. Negative 8 minus 16 is negative 24. And then what I'm confused about is if we're subtracting those, wouldn't it be plus 24?
It's final. So VF minus VI, negative 8 minus 16 is negative 24.
And you're adding, so 6 plus negative 24.
Correct. Yeah, so you guys, if it helps to put a finer point on it, this is really plus negative. Follow? Sarah, you okay back there? We need to get to a seat up closer, don't we? They're like constantly like. Megan. Guys, quiet, please. What do you got, Megan?
So, but what I did, I just like found the actual velocities and didn't know how to aggregate them.
Oh, wait.
Divided them by 2.
Um.
That doesn't mean what it would be and Pythagorean theorem on that.
That will not work. So you're saying you found, I gotcha. Okay. So you're saying you found the magnitude of the velocity after 2 seconds. So you did 1.5 squared, 4.5 squared, and square rooted it, right? This is a great question, you guys, so please hear this. These are like, because this is just my second year doing this, I still don't know the mistakes that students commonly make. And now hearing you say that, I remember I saw students do this last year. So watch out for this. So what you did is you said, I know the velocity after 2 seconds. So you did Pythagorean theorem, right? So 1.5 squared, 8 squared, square root, it gave you a number, right? Same thing over here. 1.5 squared, 16 squared, square root, it gave you a number. And then you plugged VI and VF into this equation, right? Okay, you can't do that because this equation, although I'm sloppy about it, these are vectors. Okay, so the equation is not the magnitude of the velocity minus the magnitude of the velocity. You actually have to subtract the vectors, not just their magnitudes. Does that make sense? Everybody, does that make sense?
Yeah.
All right, now, what you could have done that is similar to what you're saying, Maggie, is you could have found your average acceleration horizontally, found your average acceleration vertically, and then done the Pythagorean theorem. Does that make sense? Everybody good? Okay. All right. So, if this is my change in velocity, then we're almost done here. Acceleration is change in velocity over time. So our change in velocity is the 6I minus 24J miles per hour over, how much time did that take? 2 hours. And so 6 divided by 2 gives me 3. 24 divided by 2 gives me 12. So I'm looking at 3I minus 12J miles per hour squared as the acceleration. And then if I actually wanted the magnitude, then you can do the Pythagorean theorem and put it back together. Josh or Joshua, which do you prefer?
Josh is fine.
Okay.
Do you really want us to be done with these notes by the 19th of September?
That's the date I printed
That's the
stuff.
date you printed.
That's the date I printed.
So we're not that far.
No, I printed a lot of stuff. No, we're actually doing okay on time. Because last year I spent a whole 2 weeks on vectors, and we spent 2 days on it. So we're doing fine on time. Alex. Yeah, your name is not Alex, I'm sorry. Patrick. Everyone is named Alex.
So would AP just want it like that, or like blah 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 at?
Oh, I gotcha. So it will either specify, it'll say give the acceleration in unit vector notation, or it'll just say what's the magnitude and what's the direction. If it doesn't specify, then they have to accept either. Good? Because they're equivalent. All right, are we good? Am I going too quick? Peter, what do you got?
Yeah, if they don't specify, do you suggest anything over something else?
To me, this is easier.
Okay.
So I would probably leave it in unit vector notation.
All right.
Cool?
Yep.
All right. I'll be honest with you guys. There is not a ton of this on the AP test, but when we get to forces, understanding this will make things easier. Okay, so this is, you'll see. All right, so everybody happy here? All right, when do we get out? We get out at, holy beans. All right. All right, so this is the last thing I wanted to do today. Let's...
16 minutes left.
Tell you what, I'll make you a deal. You guys do this, I'll pass back the tests. Alright, so while you guys are digging out your calculators and putting your physics caps on, here's what I did with the tests. Alright, listen. So the test, both tests basically had... Here, this doesn't need to be... Okay, so here we go. So here's what we know. The bird is flying with an initial velocity of 5I minus 2J miles per hour. Meters per second, I'm kidding. At the instant he switches on the jetpack. Unfortunately, the jetpack is on crooked, so it gives him an acceleration of 4 meters a second at 30 degrees west of north. Find the bird's instantaneous and average velocities at the end of 5 seconds.
So accurate acceleration should be seconds squared, not meters per second.
Thank you. Cool. All right, so somebody get me started. What should I do first?
Same.
Ooh, draw a picture. Awesome. All right. I'm okay with that. So let's see. My initial velocity is this. Right? That's my initial velocity. My acceleration, we're going west of north, so something like this. Here's the 30 degrees, right?
Yep.
This is 4 meters a second squared. What should I do? Sarah, thank you.
Find the horizontal and the vertical side.
Yes, high five. Yes, find the components. You want to work in components. You want to work in unit vector notation. Okay? Because there's no equation that we have that will accept this. Because you can't put 30 degrees into your calculator. Well, you can, but you can't put, you know what I mean. All right? So, find your components. So, my AY is whatever 4 times the cosine of 30 is.
Wouldn't it be 2? Or no.
Nope, the opposite.
2 or 3, but I don't have the exact.
Darn it.
Sorry.
Why can't you guys make me be more prepared? 4 cosine 30. 3.46. Positive or negative? That is forever immortalized on YouTube.
Thank you.
All right. Are we all good with this? All right, our AX is -2. Everybody good? All right. Hopefully you're all thinking something super duper helpful and important right now about that acceleration. Oh, somebody said it. Constant. Good. Very good around here. Yes, it is constant. Why are we excited that it's constant? Now we can use those kinematics equations, right? All right. So here's my acceleration. It is -2I plus 3.46J. The question wants to know the velocity at the end of 5 seconds, right? So check it out. VF equals VI plus AT. So let's see, my initial velocity was something that is written at the top of my page that I can't see anymore. 5 minus 2J. 5I minus 2J plus my acceleration is -2I plus 3.46J times 2 times 5. That's what I said. All right. So how do I deal with this? How do I take this vector and multiply it by 5?
Distribute the funds.
You just distribute. Okay? That's called multiplying a vector by a scalar. So you distribute. So now I've got negative 10i plus whatever j, and then you just add component-wise. Make sense? All right. Now, finding the average velocity is going to be a little trickier. We don't have time for it right now, but what you'd do is you'd find your horizontal displacement using your horizontal components. Find your vertical displacement using your vertical components, and then do displacement divided by time. Kim?
Why do we need VF plus VI divided by 2 if
Just
that's
constant
acceleration?
acceleration.
Oh, you could. That's even better. Yes, high five. Awesome. That's even better. I love that. Df plus vi over 2 because the acceleration is constant. Bad A. Really good job. Yes. All right. Questions?
That's it.
The VI on the other side. VI.
Plus vi over 2.
Oh,
And the time isn't 2.
I did the delta t over.
Yeah, so Cam is 100% right. To find the average velocity, you can just do VF plus VI over 2. We know our VI because it was given to us. The VF we just found. Add them up and divide by 2. Awesome, yes. But we can only do it because the acceleration is constant. Good, you guys? All right, so try to finish the chapter 4.1 homework for Monday. It's not that long. All right, I know it's a busy weekend, but it's not that long. Yes. Which one? This? This? Yes, but our acceleration is constant. So the constant acceleration is the same as the average acceleration.
Other whiteboards.
No?
Someone got rid of the red copy of the out of the field.
Contraction is no.